Hello, this is Sean Mullery from Electronic Engineering at IT Sligo, and what I'm going to cover in this lesson is the last part of the linked list program, which is the delete function. The important things about the delete function, the way this is supposed to work is we send it the value that we wanted to delete, and it has to try and figure out firstly, is that value in the list or not. If it's not in the list, then what it will do here at the very end is that it will return this basically, which is the null terminating character. It'll basically return that and say, look, the item wasn't in the list. But if we do actually find it, what it will do is it'll normally return the value that we've passed in to say that that value was actually found. So it either finds the value and deletes it, or it doesn't find the value and it tells you that it couldn't find it. Now, one of the important things that I mentioned previously with dynamically allocated memory, and remember each item in this list is dynamically allocated, is that you must free up that memory. And here in the delete process is where we will free up that memory. So as we delete an item, we need to free up the memory that's associated with that item. So you'll see here in many cases throughout it where we have freed up the information that is related to the particular address or pointer that's associated with that piece of storage. So that's important that we get that done. Similar to the insert item, what we make is 3 different pointers that are related to our search. We have the previous pointer, which we always like to keep account of where we were previously, just the last pointer, because in this case, what's going to happen is we're going to keep the previous pointer, the current pointer, and in doing that, we're going to have to delete one of the items, and we're going to have to then attach the previous pointer to effectively the next pointer. So it's vitally important that we keep count of the 3 different things, because there's a danger we'll delete something and then lose track of where we were, and that's effectively like breaking a link in the chain, and we can no longer keep the entire linked list together. So we've got a previous pointer, a current pointer, and a temporary pointer. Temporary pointer is usually there to just kind of keep a temporary copy of a pointer until we no longer need it, and at that point then it can be removed. So once again, what we pass into this, and remember that this SPTR, as I mentioned, is a pointer to a pointer. So the thing is here that this is pointing to the start of the list, but because the start of the list could always change, and back in the main program we need to know that address has changed. Therefore, we actually need not just a pointer to a link to one of these list nodes, but a pointer to a list node, so that that very first pointer there always maintains the value that of the current start of the list, and that means that in our functions we can make a modification to that and it updates it back at the base. Okay, so what we do here, the very first if statement here, is that we check the value that has come in, and we check, is that equal to the data that's associated with the pointer at the head of the list. Now remember, as I said, SPTR is a pointer to a pointer, so that's why we're dereferencing it here first. You can kind of think of this as being something with 2 asterisks. So we've 1 asterisk to dereference it, and then we also have the arrow to actually go to that list node and get that data. So we're checking, is it equal to that data? If it is, that means that we've found the item that we're looking for, and we've found it at the head of the list. Okay, so we found it at the very, very start of the list. It was the very first item. What we do in that particular case is that we now update, or we keep a temporary store of the current start of the list. Okay, where exactly that is. Okay, so where's the current start of the list? What we then do is we move from there to the next pointer along the way, and we change the start of the list to now point to the next spot along the list. So this is like getting a chain and taking off the first link. Okay, but the important point is that we do need to keep a record of that first item, because what we then need to do is we need to free up that memory. Okay, now if we do that at that point, this returns out of the function with a 0 there straight away to say that the function has finished. Okay. And what we'll do is we'll just go back to where the delete function is called, so we can see what these return values are actually used for. So So this is case number 2. If the thing is empty, if the thing is not empty, what do we do? So we call delete and we send it the start pointer and the item. And remember that if it comes back with a 0, that means that the item was not found. Okay, and that's what we put there. Now I'm a little bit concerned about that, because that suggests then that if we delete the item at the start of the list, which is what we have in this case in our delete function, if we delete that item, that we're returning a 0 here. So I'm just going to test that. I'm going to run the program and see if that happens. Okay, so I'll add 1 or 2 items to the list first. I'll add a G, then I'll add an A. Sorry, I need to say 1 first and then add an A, and then I'll add a V. Okay, now I'll delete an item from the list and I'm going to delete A. And it says A is not found, which is clearly a mistake. Okay, so I don't know if that's a mistake because I don't have the original program here beside me, but clearly that is a mistake, because A should have been found there. So I'm just going to see if that has been removed from the system. So I'm going to put in another character, a H, and we can see that the A has been removed, but it's come back and told us that A is not found. So I think that's a mistake there at that point, that what we should really be doing is returning the value there. So I'm going to change that. Okay, and really it's only down here where if the item is not in the list that we should do it. So that's probably just a small little mistake on my behalf as I'm writing in the program. Now, okay, so that's if it's at the very beginning of the list, and that's important that we take care of that situation, because the very beginning of the list has a link back to the main program where the start of the list is. The one thing we don't want to do is remove the chain from the information that tells us where the start of the list actually is. So if it's anywhere else other than at the start, in other words, if it doesn't equal the first piece of data, what we then do is we then start to move along the list as we did previously. So unlike if it's at the start of the list, where we really only have to worry about making a link to the start, or basically changing where the start of the list is, we now have to make a break in the chain, remove one of the links, and then link them back up again. So that's what we do here with this this first section here. We put the start of the list, we call that previous pointer, and then we put current pointer to the next item along. And we know we've already checked with this if statement up here that the data is not in the first item. So we're now looking at the second item in the list. Previous pointer still points to the first. What we then do is we go through a while loop where we constantly move through the list. So each one of these, previous pointer becomes, the current pointer gets put into the previous pointer, and the current pointer then moves on one step. And what we're looking for here is, have we reached the end of the list? And I know that's an and there, but I'm saying the opposite of what's happening here. So this is, we continue if we haven't met the end of the list, and we also continue if we haven't found the piece of data. Okay, so to get out of this while loop, we either have to get to the end of the list having not found the data, or we need to have got partly into the list and found the data. And at that point we need to figure out, well, why did the loop end? Was it for this reason here, that the current pointer not equal to null? That means that this was not the reason that we finished the while loop. It wasn't this one. So it must have been that we found the data. So if that's the case, then what we have is we save the current pointer, the one that we're currently pointing to, into the temp pointer. And same as last time, we're doing this so that we can then free up that memory. So when we take the link out of the chain, we still need to keep a hold of it so we can properly dispose of it. So that's what we do there. We then get the previous pointer, which is the pointer to the previous link. We take its next pointer and attach it to the current pointer's next pointer. So this is effectively bypassing now the current pointer. And we then free up the temporary pointer that we had saved up here. So that's the address of the link that we're deleting. And we return the value at that point. Okay. If we've got all the way to here though, and we've obviously reached the end of the list, and therefore we didn't find the item, then what we would do is return the null character there. Now we could also just return 0 at that point. That would also do the same. We could just return a 0. It's effectively the same value. So one or the other. But the reason that they've put in the return 0 like that is that this is expecting a character back. So the null terminating character is effectively 0, so we're as well send it back as an actual character. That's the only reason that they've gone and done that. So that's the delete function. I'm just going to run the program one more time since I made those changes. Again, I'm going to put in the letter D here. I'm going to put in the letter A, and I'm going to put in the letter Y. Put in a capital Y. And I'll put in a fourth letter as well here. Put in the letter S. At this point, I'm going to delete, firstly, I'm going to try and delete something that isn't in the list at all. So that's the letter C. C was not found. Okay, I'm going to try and delete the letter A this time. And A is now deleted. So that was a mistake that I had in the program in the first case. So that's now fixed. And we can also delete something like the S there from the middle. So I'll delete S here, and we can see that D now attaches to Y, and that's the little arrow, the next pointer to the next pointer to the next pointer until we get to null. Okay, so hopefully you've followed that. Now linked lists are notoriously difficult to explain, and also I find them easier to understand than I do to explain. So hopefully you've got some idea of it there, and obviously have a read of the program, and we'll see how we get on with that.